And now let me introduce you today's speaker. Preeti is a seasoned technology leader with 16 years of experience, including expertise in React, React Native, Flutter, and native Android and iOS SDKs. She is proficient in clean architecture, microservices, and tools such as Android Studio and Xcode. Preeti's leadership skills extend to project management, risk mitigation, and resource allocation anchored in Agile and Scrum methodologies. A people-centric leader, she excels in recruitment, training, and fostering collaboration, poised to drive innovation, efficiency, and high-performing teams for your organization's success. Welcome, Preeti.
Oh, I'm sorry, I'm not muted. Hello, everyone. So it's great to see everyone here. I am already excited looking at the questions, to be honest. And thank you so much, Violina. And welcome, everyone. So today we are here to explore React Native, delving into its opportunities, limitations, etc. We'll journey through its history, the use cases, the limitations, learning materials, practical next steps. And by the end of this session, you would have a clear understanding of React Native's potential and the resources to kickstart your learning journey. So if we all are ready, let's start on it and let's move ahead. So I would not drag too much on the introduction as we already are aware of native Android and iOS platforms. So React Native is a powerful framework that revolutionizes mobile app development by allowing developers to use JavaScript to build cross-platform applications. In coming slides, we'll explore how it works and why it has become a game changer in the world of mobile app development. And we'll look around on the purpose, why we're using React Native, what happens behind the scenes, how we'll unravel the magic of how this code written at one place is running at on both the platforms. So let's dive into a quick history on React Native, but we'll keep it brief, as I already mentioned that we are familiar with iOS and Android native development. So the big problem with the companies to target both platforms. Now you traditionally need two separate team of developers when we're going native, which is costly for small companies or for projects which are not that, revenue generating, and it's inefficient in some cases. Looking at that, the next such solution that came into the market was Cordova, Ionic, and PWAs, which used web technologies to mimic native apps. But then since it is a mimic native apps, they fell short in performance and consistency. And moving ahead in 2015, Facebook introduced React Native. This became a game changer in mobile app development. This React Native leverages JavaScript and allows you to build cross-platform apps for both iOS and Android with a lot of ease. So no more separate teams for small companies or compromises, just the power of JavaScript, one team, and you can run your application on both Android, iOS, Windows desktop, web, and different platforms. But here we'll confine to mobile since we are discussing mobile. Now, before we get into how React Native is working exactly, we'll see why do we want to actually go ahead with React Native. One, the three main reasons that I see for React Native, one is big companies. The major industry players like Facebook, Uber Eats, Instagram, Discord, and Skype trust React Native for their applications. All these are built in React Native. And additionally, there are giants like Shopify, Walmart, Microsoft who have heavily invested in React Native, validating its reliability and scalability. So for people who have question about, is React Native stable? Will it leave the market? No, it's not going to happen. React Native is quite stable and it is backed by big brands and giants, so it's very safe. Now, next coming to big community. So React Native boasts a vast community, ensuring ample resources and documentation for support. This community is driven. This is community driven ecosystem offering solution to challenges and wide array of libraries and tools, making development much easier. So this is not a naive technology where you would not find any support or a few functionalities are restricted. You have almost every functionality covered in React Native. At the end of this presentation, I'll also speak about my own experiences, the kind of apps I have built, which will answer one of the questions which was posted in the FAQ questions chat. Next benefit is cross-platform capability. So React Native enables cross-platform development, allowing you to write code once and deploy it on different platforms. So this eliminates the need for separate development efforts and ensures seamless integration with native code when needed. So in essence, React Native combines your support. It is backed by big companies. It has big community and it is cross-platform. So it is a game changer. Now let's unravel the magic and understand what happens, how React Native is exactly working. And I'm sure most of you will be interested in this part. So the idea behind React Native is to combine two separate pieces, JavaScript code and your native code. Now, native code, we are already aware of Java or Kotlin for Android and your Objective-C or Swift for iOS, as we see here. Now, React Native is all about making them work together with JavaScript. While native code will be executed directly on your device, like when you run your application on Android or iOS, JavaScript needs a virtual machine to run on. Now, iOS devices have a built-in JavaScript engine because Safari uses that JavaScript engine called JavaScript core, which is written in C++, which will compile and execute our JavaScript code. Okay, and Android devices don't have a built-in Java engine or JavaScript engine or a JavaScript core, and that will be brought into iOS along with the React Native framework. So when you see the builds generated with React Native for iOS and Android a little heavier than iOS because of this extra load. Now, since Java or Objective-C and JavaScript, all these languages are very different. They have no connection. They cannot speak directly to each other. They can speak indirectly. We need to make them speak indirectly. It's like, a person who can speak Spanish is talking to a person who can speak English, but both know only their own languages. So in that case, you need a common language which both of them can understand, like in this case, which would be JSON. Now, this communication, like in that example, will be handled by a translator. Here, that translator is nothing but your bridge, the bridge which is highlighted here, which is bridging your communication between JavaScript virtual machine and your native components. So what happens during your runtime is your native code is written in Java or Objective-C, will be compiled into your Java or C++ binary files. And the JavaScript code which you have written will also be bundled using a Metro bundler into .js. Now, this Metro bundler works similarly to Webpack bundler used in web development, but it is optimized for React Native. Now, this binaries and JS bundle will eventually be packed inside an executable file, which is your .apk or your .ipa for Android and iOS respectively. So till here, what are we doing? We're just taking our code, what we have written on JavaScript and our native Java and Objective-C code, packing it into a single bundle and creating a executable or installable file in a very simple language. Okay. Now at runtime, now what happens when you actually install this application and open it? That is runtime. Shifting towards the right side of the diagram. JavaScript code will run on your JavaScript virtual machine and your native code will run on your device. Now, what happens when you run this application is your bridge comes into picture, where bridge will transfer your serialized messages between the two blocks. These messages will then be deserialized and then processed for the app to be interactive. we'll understand this. So let's look into the threads to understand this more better. So what happens when you run an application? A device will start 3 main threads. Okay, one is JS thread, which is for JavaScript. One is shadow thread and a main thread. And there is other background threads as well. If you have background functionality or different sorts, let's discuss these threads one by one. So there is a main thread. This thread is the main thread on which the application will run. It is responsible for user interaction and rendering your UI. So this is the thread with which you will be interacting when you open your app. And it is the same thread that is running in every fully native build application. Be it native or React Native, the main thread is where you'll be running your applications on iOS and Android. Now, what comes into picture is your JavaScript thread, where the business logic of the application will be executed. That is your JavaScript and React code. That is only for your business logic, the JS thread. Now, there is another thread, which is your shadow thread. This thread will be launched along with JavaScript thread. Its responsibility is basically to compute the position of the views and construct the trees and layout. So whatever you're seeing, the layout, the UI and everything, whatever you see on your application is constructed and positioned by this shadow thread. Now, React Native utilizes a layout engine called Yoga, which converts your Flexbox-based layout into a layout system that native can understand. So I'm sure you all are aware of the Yoga, which is for iOS. And so your UI which is written in your React Native is using Flexbox, and that UI is converted into your given to your Yoga engine and converted into a native UI, so that the host, which is your native platform, be it Android or iOS, can understand that. Now, there are few cases where you write native modules. That is, when the application needs access to a platform API, like for example, device storage, or like one of the person asks biometric or camera or location, etc. In those cases, this background threads come into picture. These threads will handle it. So in short, React Native makes the app by blending JavaScript and native code using a bridge to make them talk via a common language called JSON. Via a common format called JSON, and organizing everything into threads for the phone to understand and use it. Okay, I hope there are no questions. It's understood, and I'll definitely take the questions at the end when we have the Q&A session. So this is how, in short, your React Native works at a very... Now let's see a simple example. Okay, let's spend 2 minutes on understanding this. Imagine a React Native bridge is initiated here as a messenger. Now, how it works is, imagine you have a simple touch event that you have made on your application. Now, what happens is, after this touch event or a scroll event or whatever, the serialized message is sent from native side through the bridge with all necessary data. It will send the event that there is a touch that has happened on a button, say for example, and that is sent to your native bridge. So through the bridge, it is deserialized, it is serialized and sent through the bridge. JavaScript will receive the message, deserializes that, and decides what to do based upon the code that we have written. Okay, then the message sent from the JavaScript layer through the bridge will inform the requested action. The native side receives the message and then update the view. So this is how the bridge will act as a communication medium between your JavaScript and your native layer, and all these threads and the bridge together make that rendering and your interaction possible on the application. Now let's see how our Java code is basically, you code that you write in React Native is working on your platforms. When we write our code for user interface in React Native, we're basically creating instructions in JavaScript for how we want things to look and behave in our application. But how does JavaScript code turn into actual stuff we see on the phone is what we're going to look here now. we start by writing code using React Native components. So in React Native, you have components like view, text, button, which are not understood by your Android or your iOS. They are there, but have different terminology and different names there, right? So once we have written our UI code, React Native does behind the scenes magic. It compiles our JavaScript code into a format that our devices can understand. Now, this compiled code includes not only our UI instructions, but also any other background business logic that we have written for our application. Now, this compiled code is sent to our devices. And when we open our app, React Native Framework takes these instructions and uses them to create your native views. Like Yoga in case of iOS, it will take these views and then generate corresponding views for text and images, like corresponding image and text views on iOS and Android devices. So these views are native and they are rendered as per the Android and iOS layouts, like, the restrictions that we have on the devices, the top notch, and then the buttons at the bottom, and etc. So once the native views are created, they are rendered on our device screen, which means they're displayed in the right places using our thread. Again, those positioning is done. Our main thread is catering our application. Our shadow thread is going ahead and displaying all the things for you. And your JavaScript thread is waiting for the interactions and your business logic to be run. When we interact with these views, like tapping on the button or entering text, the React Native framework takes care of translating those instructions into actions that our JavaScript code can understand. This is where your bridge will send the communication, like we saw in the previous diagram here. Yeah, the interactions are sent, serialized and sent to the native layer. They're deserialized JavaScript. They are deserialized. Actions are identified, sent back to native layer, and then that is how you do your interaction with your native code. So this is how you write your code in React Native. And in simple words, I would say React Native is like giving instructions in JavaScript for how we want our app to look and behave. And React Native then takes these instructions to convert them into native views for both the platform and handle all the interactions and the business logic and run the app smoothly on the devices, giving them a native experience. So this is how React Native works in the background. I hope it's all clear. Now let's dive into various ways where, use cases where React Native is useful in your mobile app development. So first scenarios, we have rapid prototyping. React Native is fantastic for quick creating prototypes of mobile applications because it allows developers to iterate and test ideas rapidly, which is crucial in early stages of development. Now, next we have a cross-platform compatibility, which we have already discussed. So I would just skip that to save time. And then another key benefit is code reusability. Now, as I said, you write the code once and you can use it on different platforms. I don't mean only for iOS and Android, but you can also use this code for your React Native web to create web applications for Microsoft desktop applications and with different platforms with very ease. You can just make reusable components and render them wherever you like. So that is one big benefit that you have, which is code reusability. Now, I would like to give you some examples of successful applications that are built on React Native, which the biggest example that we see on a day-to-day life, I am sure everyone uses Instagram. So it's the most popular social media platforms, and it uses React Native extensively in its application. And similar example is Facebook again, which is again a social media application, which is no surprise. It's built by React Native and enable Facebook to completely use React Native in every way possible. And another famous app that is using React Native is Airbnb, known for its intuitive user interface and seamless booking experience. So that is also built using React Native. So these examples, demonstrate the versatility and effectiveness of React Native in building high quality cross-platform mobile applications. And there are a lot of other, domains also where React Native can be used very easily, be it e-commerce or medical or biometric or integrating with any external devices like, scanning devices or your camera, locations, Bluetooth, anything. It's very effective and works seamlessly. Now, there are, like one of you asked, are there any limitations to React Native? Of course, there are limitations, but over the time, I would say it is not as it was back in, if I look 5 years, 6 years down the line, it was not as good as it is now. React Native, since there are the threads concept come into picture, heavy graphics or animations. If you want to build heavy graphics and animations, while React Native is excellent for building most type of the app, it will struggle a bit with heavy graphics and complex animations. Because in that case, your JavaScript thread and your main thread both are working on the animations itself, right? So in such cases, we would either go for platform specific tools, or in cases where we want platform specific tools or want to enter more into the kernel level functionalities of your operating system, then yes, I would say go for native development, because then you need concurrency, you need to get into the native layers, you need to get into the OS layers and do too much on your kernel level functionality. So that yes, of course, I would not suggest React Native in those cases. Then there are a few challenges, as I told already, when compared to, when working with your uh, heavy animations and complex, multiple thread concurrency needed. There you have little performance issues. And you have limited access to your native APIs, definitely, because you have to go and implement them in your native modules as you usually do, and then expose them to your JavaScript layer using your bridges and all that. So there is the limitations where you have only native APIs, like in the case of TensorFlow or something, where they are not present for React Native, they are only there for native integration. So in those cases, yes, it will become a little challenging. So these are the limitations, and there are some valuable resources that you can use to learn React Native efficiently. First, you have React Native official documentation, which is awesome. It is very simple, has complete guide A to Z of React Native. Next, you can also consider enrolling into online courses, like you have you on Udemy or Coursera or YouTube as well. There are a few books as well, but then books, again, I am not a big fan of books because then you can't upgrade them. You don't have the latest content. So yeah, there are a few books. If you are a fan of book, then you can go ahead with books as well. Then you have, as I said, it is a big community. So you have community forums, you have React Native community, like Stack Overflow is awesome with that. You can follow your fellow developers and seek guidance there also. There are hands-on practical, hands-on is crucial. So we have tools like Code Sandbox and Expo, where you don't need any setup. You just go select React Native and start coding. And also I'm excited to announce that we'll be launching a React Native study group soon. It will be a convenient collaborative platform for learning, discussing, and sharing resources. So you can stay tuned for more details. We are launching the React Native study group for front-end and mobile track. So by utilizing these resources, I'm sure you can, and participating in the upcoming study group, you'll accelerate your journey to mastering on React Native development. And you can also keep an eye on the events page, and we'll post the launch of the event once it is planned and scheduled. At this time, we're waiting for people to register and based upon the registrations or people interest, we would decide on when do we want to start the study group. So you can keep an eye on the events page. And next steps in React Native, if you want to pursue React Native as your choice, or you want to explore React Native, is then you can go ahead and install, if you want to do the installation or set up the environment on your local, you can install Node.js, because it runs on your Node, it needs Node.js to run your JavaScript code, of course. Then you can go ahead and set up your React Native CLI. Or as I said, you don't want to set up anything, just want to experiment, go ahead and use Expo or Code Sandbox, where you can just select Expo, again, directly is for React Native. You need not select there, but Code Sandbox, you can go and select React Native and then start building your application directly. Building your first Hello World React Native app. Go and take a feel of how React Native works, understand the basic structure of React Native app, explore the components and styling, and then you can understand how you're writing code at one place and then it is running on both the platform. You can see the difference. I'm sorry. Explore components and styling, learn about React Native components, how to style them using CSS like properties, Flexbox, etc. There are also advanced topics that you can explore that are navigations and state management and etc. So you can deep dive into solutions like React Native navigation, which to create a multi-screen application. Like in case of Android, we have our intents we give for fragments and multiple activities and screens. Then you have state management where, you have, like we have our uh, data persistency and to maintain the data across the application. So we have libraries like Redux and Mobux that manage state of your application efficiently. And these work wonderfully. I totally love these libraries. And finally, it's time for questions. I think I've saved a lot of time because there are a lot of questions. And before I give open the floor for questions, I encourage you to share any queries or experiences you want to know you have with React Native, or if you want to understand anything further, you can connect with me on Slack. I am very much active on Women Who Code Mobile and Front End Track Slack. You can ping me one-to-one or drop your queries, tagging me. I would definitely answer them. You can connect me over LinkedIn or drop me an email if you want to discuss further or gain more insights that you want. So thank you all for listening to me and being patient with me. I open the floor for questions and it's your turn to talk now. Shoot.
Thank you, Preeti. Amazing talk. Hope that people are excited about React Native. We have a lot of interesting questions. And the first is it true that cross-platform is not as efficient as native mobile development?
I'm sorry?
Is it true that cross-platform is not as efficient as native mobile development?
No, I would not. I would say no to that because I personally have developed so many React Native applications, and I would, if everyone wants to look at, what kind of, I'll just give you a link to application. You can go ahead and search this on iOS or Android. This is an application which has almost all every functionality that a native app would want to have. But, we have done this using React Native. It uses maps. It uses geolocations. It uses camera. It uses your canvas to draw your things. It uses your extensive customization of Google Maps. It uses animations. It uses native modules like, location sharing, etc. So this app has almost all everything which we have built on React Native, and it performs seamlessly. So it is not the case that React Native apps are not efficient, or the platform is not as efficient as native. Of course, native is efficient, but React Native has come to a level where it is able to support every functionality on your React Native.
Great. Thank you for answering this question. Another great question. Do you think another framework will take over React or React Native?
See, I would say to that, there might be new frameworks coming in the market, or they might not come. But then, even if I speak about a social application, if you want to launch an Instagram today, do you think you can capture the market as fast as the Instagram today? No, right? Because you need to develop that kind of trust. You need to develop that kind of, a learning curve, and people to trust you, companies to trust you enough to get you moving into that technology. So even if there is a cross-platform which is coming in future, it will not kill React Native, because as that technology is being introduced in the market and picked up, React Native is also growing parallelly. So it will not die.
Yeah, I totally agree with you. Another question, how we can compress the Android build APK's file size?
Well, if you want to compress it, at first I would need to know why is your size larger, because there are multiple factors because of which build size are huge. It may be because of your images or because the data that you're holding in your bundles, because of your the way you're installing your libraries, the dependencies that you're using, etc. So I think this answer would more depend on what kind of factor is increasing the size of your application.
Yeah, you're right. Thank you for that. Another question we have, can React Native apps use App Center to detect crashes in your apps?
I'm sorry?
Can React Native apps use App Center to detect crashes in your app?
Crashes in the application, App Center, honestly, I'm not very sure about that. I've never used App Center with React Native, and I guess you can use App Center, but for crashes, for catching your crashes and errors, and what kind of, again, this also answers another question I guess we had regarding debugging. I have heard it is difficult to debug on React Native and find the errors, etc. Right? There was one more question. So I would answer both at the same time. Debugging on React Native is very simple. Whenever you run your application on a simulator or on your device, you just connect your debugger, which is on Chrome or any other browser, and then you start debugging your applications like we do on Android or Xcode. You attach a checkpoint, you put checkpoints and attach a debugger, and you can go ahead and see your data and everything. Same thing is possible on your React Native application as well. So debugging, absolutely easy. Now, second, coming to catching errors. Catching errors is also very easy. We do have error handling, try catch blocks everywhere. We have error boundaries. We have tools like Sentry, Bugsnag, Firebase Crashalytics, etc., which we can integrate to our React Native application to catch all your crashes and your bugs. And we also can go ahead and put our custom error catching mechanisms if you want to handle more deeper, or that kind of error handling if you want. So it's quite very possible. Now, coming to this question of using App Center in React Native, well, just maybe if you can react with a thumbs up or thumbs down and say, you're talking about the Visual Studio App Center, right? I can't see anything. Okay, assuming that you're talking about that. So if you want to monitor your application using your App Center, VS App Center, yes, it is possible to integrate it with React Native also. If you go to the documentation of App Center, you'll have the steps that that you need to follow to integrate it with any kind of application, not just Android and iOS, but it also integrates with your Xamarin and even more. So React Native as well. You can go ahead and check on the steps. So it is possible to integrate.
Thank you, Preeti. We have another question regarding security. How is the security of a React Native app? When bridging the code, does it ever create insecure Swift Kotlin code? I imagine that would be a difficult security hole to fix.
No, of course. See, when React Native is, of course, using bridges, it is using this platform to put your native JavaScript code into your native layers, but definitely doesn't have any leaks because the Metro bundler is quite very secure. It takes all the precautions. And if you open the bundler, you cannot read your code at all. It is all encrypted. It is all secure. And there is no chance of your Kotlin or your Java code or your Xcode and Swift code being leaked in your native platform. So it is absolutely secure, and it takes all the security measures while implementing these bridges or other functionalities.
Thank you for answering this question. Another question, which state management do you prefer to use or you think is best based on your thoughts?
Which kind of?
State management tool do you prefer to use?
Okay, see, state management is, I'm hoping this person who asked the question already knows what is state management, and I would not get into that. So state management, if you want to use in React Native, there are multiple platforms. You have Zastang, you have Redux, you have Redux Toolkit, you have RTK queries, you have Mobex, you have your context APIs, you have direct hooks where you can do a component level state also. So it totally depends on your application. And if your application is something that doesn't require any kind of global state, I would say go for context APIs and use state hooks and all. That is enough for your application. If your application is something like a chat application or a social application where you need to have live updates, like you need to get your likes and comments and all that immediately, then go for RTK queries, because that is very efficient in that cases. If you have an offline first application where you need offline functionalities also along with your state management, you want to cache your offline request and cater to them when they are online, go for Redux state management, or Redux Toolkit is also an advanced version of Redux, which is absolutely good. If you want a simple state management, just hold your data, have a middleware, perform your interactions, go for a Redux Toolkit. Or if you want everything, you don't want to control anything, you just want someone to handle your state and you just want to use it, go for Zastang or Mobex.
Great answer. Thank you. Another question, which image extension we should use?
Image extension? As in you're asking me image library for image processing? Or image in the application?
Nope.
Then you can integrate third-party tool.
PNG or image?
I personally don't prefer using PNG or JPEG or any kind of images because of the size and the kind of rendering that is limited. I prefer using SVN, and I put most of my images in the SVN format where I can customize them as per my app theme. If I'm going for dark or light, my icons, my images are all customizable. So I use that. But yes, definitely you can use PNG or JPEG or WebP, any kind of format, depending on the kind of design or kind of images you have. And better go for PNG because they are quite small in size and good to use. And you can also use different libraries to render them. Direct image rendering is also there. If you want to use a third-party library, they're also there. But then third-party libraries, when you have direct functionality, direct component, avoid using third-party libraries as it increases the size of your, again, the packaging of your application.
Thank you, Preeti. And last question from the Q&A, and then I will go back to the questions in the chat. I had my lead who was using hash router. In React Native, I kept telling him to use navigation. We kept getting in debate.
Okay. Well, okay, your lead wanted to use hash router and you wanted to use React navigation. I would say React navigation is, of course, the standard, uh, library that we use for navigation in React Native. But hash router is basically used in React. It is not for React Native. It is for React JS for websites. So for web navigation. So I'm really not sure about this debate on React Native because according to me, hash routers are not meant for mobile.
Great, thank you. We have a question. Does React, which cross-platform, Xamarin, Flutter, etc., I should learn if I go to cross-platform?
Well, I would say don't go for Xamarin or something because again, at the end, what Xamarin or Ionic do is like you have in your native language, when we want to render a web page, what will we do in iOS or Android? I'm just using a normal terminology. What we do is we create a window or activity or fragment or whatever, and we render it in a web view, render a web view inside that. So that is how you can access your web page within your application, correct? Now, what these Xamarin and Ionic kind of platform do is they don't create a native application, but they render a web view where you can access things like Gmail. Gmail is the best example. what happens in your Gmail application is it doesn't have any Android or iOS implementation. It renders a web view where all your emails are rendered using that. So for that kind of applications, it is good. But for any kind of, complex application, you can't use Ionic or Xamarin or something like that, not a PWAs as well. So I would say if you want to learn cross-platform, go for Flutter or React Native, which are the leading cross-platforms right now in the market. Again, they both have their own pros and cons, and they both have their own limitations. But then, yeah, they both are growing well because they are backed by giants and good companies, and there's no scope, there's no failure that I see in the future that one of them will be shut down or something like that. So both of them are safe bet. You can select one based upon your interest, because if you are a native developer, then you have same learning curve for both React Native and Flutter. Because for React Native, you have to learn JavaScript. For Flutter, you have to learn Dart. You have to understand how these platforms are working. So it's your choice. But I would say go for stable platforms like Flutter or React Native, not with Xamarin or Ionic or something.
Thank you, Preeti. We have another question. React Native are not progressive web apps, right, which Apple was planning to disable once. Is my understanding right that progressive web apps uses Vue.js?
Yes, React Native are not progressive web apps. They are completely progressive web apps. What happens is, you can download them from Play Store and install, but at the end, they are not your native apps. In the background, they are again web views which are rendering in your application. They're not actual native style applications. Whereas React Native, if you see, they are proper native applications. You generate an IP and APK file which are working independently. They don't have any web view or something. They're converting all your JavaScript code into your native code and running it as a native platform. So definitely React Native is not PWAs. And if you see our slides here in the history, PWAs are listed separately separately here along with Cordova and Ionic. So yeah, they're completely different. Yep.
Thank you, Preeti. We managed to answer all the questions. If you have more questions, you can drop it in the chat.
Oh, thanks, Tanya. If you can access these slides, and if everything, as Violina mentioned, we're recording our session and it will be available on YouTube as well. So you can go ahead and refer them later as well for your reference.
Well, I want to say thank you so much, Preeti, for a really great presentation. We had a lot of great questions that our audience asked, and you handled answering all of them so well. I want to also thank Violina for doing such a great job hosting today's event and moderating all the questions. And thank you everyone for attending this event. So, yeah, we'll give folks just a moment if there's any more questions, but otherwise, great job on the talk. And yeah, thank you so much, everyone, for joining us today.
Thank you, everyone.
Yeah, thank you all for joining the session and exploring React Native with me. And again, as I mentioned, if you have anything else that you want to discuss or know, I'm very happy to connect with you on any of the platforms and we can discuss further. I would love to have any discussion that we want.
And there was a lot of interest in the chat that I saw for the React Native study group. A lot of people saying thank you for your talk, and just a lot of positive comments about the event today. So congratulations for a great job.
Since we have time left, I would just want to address Darla for your question on hash router in React Native. Though hash router is for web, but it also has a lot of limitations. Even if you're doing React.js, that is web, you can go for navigation or your other router libraries which are there for from React, because hash router again creates unnecessary calls and it will lead to performance issues. And you have a lot of handled URL paths and etc. So you can definitely go for React routers there, which is better than hash routers. And you can, in React Native, of course, navigations is the only option right now, which is good. So just wanted to address that question, didn't want to leave it unanswered.
All right, well, I think that's it for today's event. Thank you so much. Go ahead and stop the recording.